Hello and welcome to my lecture called Upgraded Tools, a Renaissance of Design Fundamentals and a Strategy for the Future. My name is Fredrik Skåtar. I am a Swedish architect and designer based in Berlin, where I run my own studio. And currently, as of 2020, I'm a guest professor at the Hochschule Anhalt in Dessau, both at the design and architecture faculties. And I'm also a guest professor at the Free University of Bolzano in Italy. So given the rapid technological development, architects and designers need a new strategy for remaining competitive. And any discussion on the tools, I argue, is a discourse also, or really on the profession itself. And this is what I'm going to explain here in this lecture. So the concept of upgraded tools is about digital design methods. So I'm giving you a little background here. And digital design methods, of course, a vast term, right? So here the focus is on specific branches of it that could not be executed in any other way. So we are talking about algorithms that can create complex geometries and shapes, such as the wave sculptures that you see here in the background that are made by me. Algorithms can also create tessellations. And here we see examples from my experience with spirals and also with the Penrose tiling here in the background. So this pattern was generated with help from Grasshopper for Rhinoceros. And then I can then apply new prototyles into this tessellation, which is quite a complex task. But finally, we can make it with help from these tools. We are also talking about simulation, which can be a visualization of design. And currently we are seeing ever more real-time simulation software, which is a very interesting development because it's much more accessible as in comparison to previously. And there are also methods for simulation of forces. So like in this case here, we see a tensile structure that has been simulated using Kangaroo for Grasshopper. And this is, of course, a fantastic form-finding tool for architects and designers. And certainly these examples are just a few, okay? So I'm just trying to create an overview of the things that these systems can do for architecture and design. But this is the creation part, right? So we also have the production part, or we usually call it digital fabrication. And here in the background, we see, well, numerical control to produce our designs. And the most established method we see here in the background is the subtractive fabrication, but usually it's referred to as CNC milling. Certainly, we have additive fabrication, which is then 3D printing, where we actually melt materials usually, or you assemble a powder so that it gets hard and so forth. And it's very many different kinds of 3D printing out there. And it's, of course, still in development, which is very important to note. And we have also something very interesting called neutral fabrication, where no material is subtracted or added, so the material remains intact, and it's like, for example, bent, like in this case here with CNC bending. In all, these methods are still new, and they are in constant development. They are sources for discussions regarding efficiency, creativity, analysis, and refinement. But in these discussions, I have detected strong polarization. So on one side, we find a group who is skeptical towards digital design methods, and they usually have limited knowledge in the field. And on the other side, we find enthusiasts. They have vast knowledge and often regard the tools as revolutionary, actually. And my position is more goal-driven. So in the future, I believe that any further discussion about design tools is inevitably a discourse on the profession itself, like I said before. So this is very much about nuances, and we have to really look closely on specific projects and examples in order to understand this. But this is an overview and an introduction to my attitude towards tools, digital tools. Yeah, so to understand this polarization a little bit better, to see what that is, let's look at some examples and explain what skeptics and enthusiasts are. So the skeptics, they have a vast design experience, of course. They are usually, they belong to an older generation. They're not so used to computers. But because of this limited knowledge in using computers, they cannot really see the full scope of the possibilities, right? So therefore, they can unfortunately not fully engage in the debate. And that's a problem, I think, because we really need this group to rationalize the debate. And why do I say that? Well, it's because the enthusiasts, on the other hand, they are then making very large claims about the future. Some of them claim that algorithmic design is a new design style. And this is a work by Zaha Hadid background. And if you know her partner Schumacher, he has actually at one point said that parametricism is a style that naturally follows postmodernism or something like this. And they are very much into seeing the tool as a sort of creative force per se. Okay. And other enthusiasts, they then, what I want to say there is, of course, that it's problematic to say that the tools have a creative force themselves, because that's not new at all. You cannot claim that it's a new style if we can compare that to absolutely normal formalism, actually. So what I refer that a little bit, I say instead of saying formalism, I usually say tool-based formalism to narrow it down a little bit. Yeah, so other enthusiasts claim that we now can simulate nature, and they actually use this as a concept and a motivational argument in their project. So here we see a robot at the ICD in Stuttgart, which is weaving a sort of web. And the researchers behind this, and the architects and designers behind this, they actually make a direct connection to the spider's web in order to motivate why this would be a better way for designing. And here we also see a chess launch, which is produced by the MIT and Neri Oxman. It's called The Beast. And this, there's been very large claims about this design. For example, that it has properties very close to a plant or something like this. And so to say, have been grown through new types of 3D printing. But this is the thing, using the word grown. This is actually a bit exaggerated, but of course it helps for marketing the product, doesn't it? I think these claims are a little bit too large, right? So you probably heard that from what I just said. But nature is indeed a source of inspiration. So why can we not leave it like that? Why the large claims? There is actually strategies for trying to make sense out of this, to make it a little bit more rational. And this is what I meant before with nuances. So for example, Massimo Negrotti, he has created the concept of the natoroid. And that is then a description of a design object or architecture inspired by nature. But when he describes the natoroid, he says that when you take that out of nature and put it in a different context, it's not more nature. You cannot refer to it like that. Now it's more a natoroid, and that has completely different properties. Simply giving it a more defined description based on the built environment, actually. What happens to a nature-inspired idea when it is taken into the built environment? So that is a very interesting argument from Negrotti. Furthermore, there are several architects also experimenting with robots. Okay, so here we see from the ETH in Stuttgart. It's Grammatio Kohler Studio, who have created drones that are then building a tower like this. And they're also quite famous for having made the robotic construction of bricks here on the Venice Biennale. So learning how to use a robot for design purposes is, of course, great skills training. That's no question about it. But the thing is, there are different levels of it. So why don't we go one step further? And it's quite obvious that some branches come a lot further. So if we are, as architects, supposed to work with robots, I think we need to go to the people who really can do it, for example, automotive business. And oh yes, we should not forget the speculations regarding artificial intelligence. Of course, this is also quite a distraction. Some claim that the designer and the architect, perhaps all professions, will be replaced by an independent-minded machine at some point. So here we see Hiroshi Ishiguro and his humanoid twin. And I must say, I mean, I met him and seen his robots and looked at them very closely. They are very well made, but they are very far from thinking themselves. You know, this is something which is a little bit exaggerated today when we talk about artificial intelligence. What does it have to do with architecture? And I would say very little, actually. For example, we can also find arguments, and I'm just going to give one example. I mean, weak artificial intelligence exists. We know that. That is part of all the great devices that we have nowadays, of course. But we have to make a distinction between weak AI and strong AI. And this is something that Searles has said, okay? And I think it's a super interesting topic for discussion, and it's also rendered a vast discussion, of course. Because some people think that singularity is going to come. So singularity and strong AI, that is more or less the same. That means that in the future, we will have a machine that can think for itself and actually repair itself and actually be creative and thus be an architect, actually. But this is very utopic and it's very hard to falsify it. We can just wonder we know already what Popper would have said about this. But here I'm showing a picture of the Chinese room, which is a thought experiment by Searles. And well, I can't explain the whole thing currently, but the thing is, I can just say that if you look at it a little bit more and understand what's going on, there's a man in a room he doesn't know Chinese, but he can still communicate with the people outside just by studying in a book. And this is what Searles says. I mean, this is the limit for a computer. So it can't really think for itself. You know, it can never learn Chinese properly, like the man in the room couldn't do it either. So this is a thought experiment. And the purpose is simply to say, from Searles' point of view, that strong AI will never exist, actually. So this is a matter of discussion, of course. Yeah, but his thought experiment is super interesting. So it becomes a little bit frustrating when we have so many speculations about the future of design and architecture based on technology. So especially because the enthusiasts are actually hijacking the discussion a little bit because they have the vast knowledge, and other people that we need, whose voices really need, doesn't really have a say. This is a huge problem currently, I think. So what can we do about this? So we need to find new ways of addressing the problem regarding future of design technology. So my idea is to base it on a goal-driven agenda, which I said before too, where the idea is the driving force and where technology makes the idea real. And this seems so straightforward and self-evident, but this is constantly overlooked because of the mere novelty and the spectacular effects of technology on the architectural debate. And one of my main arguments in order to straighten this out and get as close to the core of the profession as possible. Okay, I'm going to show this. So is to view these complex tools as part of our skills training. You know, you can see that as part of an already existing family of tools, right? But the problem is we simply need to learn how to use these. So nowadays it's much harder to learn the tools than it was before, arguably. Okay, it's more complexity in it, or perhaps it's just a matter of getting used to it. So this means making a huge effort. Arguably, we made huge effort also before when we drew with pen and paper as architects. Okay, that was also a big skill to learn. So now it's been facilitated, but also not, because the computer for some people is such a threshold. So this is what I'm telling the skeptics. They should be more open-minded and really make an effort to try and learn this. It's not somebody else's problem to solve. Okay, to digitalize their drawings, for example. And we can also try, I mean, I talked about the hijacking the debate before from the enthusiasts, right? So we can also try to label and define what they are actually claiming. So I would say that they often make tool-based formalism. I mentioned formalism before and the term tool-based formalism. I don't want to call it formalism directly because that's a very vast term. So I narrow it down and say tool-based formalism because they are actually referring to the tools the whole time in their design and motivate their design with help from tools. And we can also call it can-doism. This is a term that I'm using because some designs that are made by digital-driven architects are made because they can and not because we, the users, need these at all, actually. It's more or less because it's possible to make them. That's why we make them. And there's actually no purpose in the built environment or for the user's everyday life for these things. And also the enthusiastic group, I mentioned it before, speculate a little bit too much, and we cannot falsify their claims. That's why I said before that we can already assume what Popper would have said about that. So that's how you can approach the enthusiasts and create a dialogue here about what we are really doing with this technology. A central argument of mine is also very simple, and that is that both groups are neglecting the profession's fundamentals. And then the fundamentals here, I refer to the three-faceted synergy of artistic expression, achieved with help from technology, and given a specific function. And how do I mean? Well, if we look at the user here and go very close to an everyday life, I mean, if we neglect like the skeptics, they actually neglect the technological facet. We can make them more modern, and also in the design process itself. If you're not aware of what is possible, then you might actually indeliberately neglect the technological facet. But that's a matter of discussion. What is more clear is actually that the enthusiasts neglect the content. And what I mean by that here is not the technological facet, obviously. They neglect the artistic expression and the functional facets. And this is a huge problem. Especially, I must say, the most is the artistic part, because that is usually motivated with help from technology and not motivated because of the user's need for a specific appearance or feeling or something like this. This is completely taken out of the debate very often, which I see as a huge problem. So after having thought about this for a while, I believe that a common thread could be to view the tools as the same tools we had before the digital era. So that's why I'm saying upgraded tools, okay? So these tools have been upgraded, okay? Extended. The thing is that all these tools are to a very large extent connected to concept created a very long time ago. So if you use Grasshopper, without geometry, you can't really use the software. You know, so the thing, what I'm seeing here, what I'm also always saying very often, is that I use the word finally and emphasize that word, because finally we can use all these old concepts and actually convert them into reality and use them for our ideas with help from today's technology. And this is of course fantastic. But the question is not only how we do it. What is our main focus? Is it the user, or is it simply some kind of an experiment testing what the tools can do? And I think we should actually focus much more on the former. So when I'm saying that, we are not talking about some tools anymore. We are talking about the discussion. We are talking about the profession itself. That's it. What we have to define our roles for the future based on technology, and not let ourselves get distracted from it. I have a small. My ambition is to create a framework for straightening this out, and this is a proposal, of course. And I currently see this framework called upgraded tools as three-faceted, three different branches. So first we have an attitude towards technology, and then I have something called Renaissance of Fundamentals, which I briefly mentioned just now before, and also we have to consider the underlying system of design, which means where does this come from? Why is it like this? What does it have any connection to societal development or trends or whatever? So this derives from my professional experience. It's my research on algorithmic design and digital fabrication that has brought me to these thoughts. Okay, I have used such technology in real projects, in architecture, in product design, and in automotive design, and I have then gained a very good look at how the tools work in a real situation, instead of all these sketches that are made that are actually not really finished. So here, in all these cases, we have had a very exact goal, namely to satisfy the user's needs. Okay, and that is completely different. It makes a completely different attitude and approach towards all these technology that we have currently, and it's very different from the examples I showed before, coming from the enthusiasts. And my research, it also, of course, comes from my engagements in lectures and debates on the subject, and certainly it's an important. These ideas also come from my experiences as a lecturer and professor. So to discuss our attitudes toward design technology is essential, because there are currently many confusions about this. So to illustrate this just as an example, so you understand a little bit what I mean, I can use my wave sculptures, and the first question I get when I exhibit this is almost always if the water is real, okay? And that is that the skeptics, they do not appreciate the work if they interpret it as if the computer has made it. And the enthusiasts, on the other hand, they really want it to be an exact simulation of water. This is their fascination. And both of them get a little bit surprised when I answer, because I always answer that the idea was the driving force. And then it's not so important which tool was used, right? So algorithmic design is simply part of a toolbox currently, because I worked until it resembled water from my point of view. My process was much more about composition, and if the simulation was exact or not was completely irrelevant. Yeah, so we have a lot of tools now. So this is part of a tool family, from pencil and paper to an algorithm. Another example I can make is the feedback on my research on three-dimensional tessellations. So this was when I worked at Lund University, and it was quite made some quite attention with these images, I think, because they look pretty spectacular or something like this. And it's a quite complex system, how to generate it as well and stuff like this. But the comments were always like that. It was interpreted as this would be merely decorative. And I always got then questions regarding if this geometry could be something more. Could it be architecture or design? That could perhaps be interesting. So here you see my Penrose pattern in the background again. But more important is that we need to distinguish between design proposals and design investigation. So the decorative is complex enough. That's what I usually say. And there's the whole profession of satisfying the user's needs is also complex enough. And skills training your own skills, learning the tools is also complex enough. And it's an essential part of the architect's skills. It should be a self-evident part of our profession. And then what I say there is to simply train your skills. So therefore, another attitude towards digital technology is to see it as a form of skills training, alongside drawing and sculpting. So now, like I said before, from pencil to drawing and sculpting to the algorithms, to the simulations, I mean, we simply added it to the toolbox. I don't see the digital technology as some kind of an own field, which is very often alleged, at least in academia. So, which leads me to the fundamentals of design, because once again, if I say that it's part of skills training, these tools are part of a tool family, we are actually talking about the profession. The fundamentals of design and architectural profession has been very nicely formulated by Trachtenberg and Hyman. And this should come as nothing new to you, actually. It's quite straightforward. So they say, without solidity, it's dangerous. Without usefulness, it's merely large-scale sculpture. And without beauty, it is not more than utilitarian construction. And this is something which has not changed much in 2,000 years. I mean, already Vitruvius said something similar, right? So we need to discuss the 21st century's version of Femitas, Utilitas, and Venustas. But the thing is, if we open this package, it can get very messy indeed, because it just gets too large. So what we need to do, we need to realize that this is already there, which everybody knows, of course, but we also have to look at specific relationships between the object or architecture to the user. So architecture and user, we have to look at that relationship in everyday life and then tie it to these facets. So from an artistic expression point of view, how does the user relate to the specific object? So we have to go in specific projects and look at it very carefully. That is the absolute the strategy that I want to emphasize here, because if we start talking about the facets, we can get very lost. And furthermore, you can also say that the user we have to investigate the user's relationship to the object from a technological point of view, and also from its function and application or placement in the built environment, right? So this is then has to be narrowed down to the specific project. And it sounds very self-evident, right? But I think it's very often overlooked, both in professional projects and in academia. And this is something that I want to really discuss. It's super interesting to see if you have the same kind of experience. So instead of, I also see a lot of specializations. We see architects specializing in specific things. We see designers going the other direction. And this is also something that contributes to a working process which is not holistic. And I want to emphasize that we really need to be holistic in the future. And that means to have an overview of the project and to have an understanding of all the participants in this project, from engineering to workers to how things are produced. Okay, because otherwise we will actually perhaps lose ourselves when we try to take one of those roles, because that we should not do that. We should remain architects. That's what we should do. That's our task. And that means then to stick to our trade, actually. But we have to really discuss what our trade now is. Now I'm saying that it's this holistic view, an overview, and you have an insight, but you don't become an expert on the things that an engineer should do. Or you should simply have an understanding for statics in that particular example, and make the statics be part of the architecture. And that's why we have to examine the three facets that I talked about before. So, I mean, what I mean with this overview is that if you're an architect or a product designer, you should not stick only to that. You have to understand the underlying system of it, or larger scales. That's why I always say that both the product designer and the architect, we need to understand the urbanist's ideas. And I have specific examples where this is actually completely overlooked when it comes to architecture, especially. But also in product design, especially if product designers are working in the built environment, like in a public space. But then we can go on, because the urbanist and the product designer need to understand the concept of a building also, and urbanists and architects must, of course, understand the ideas of product design. I think we should all be able to understand how a chair, for example, is produced, how it's constructed, and what its main principles are. We don't need to, architects, they don't really need to be experts in it, but having no insight at all is quite detrimental for the profession. And these things are better understandable, actually, if we can use technology, all this interesting production method, and understand this and train our skills, and then we will actually get access to knowledge of, for example, how to make this chair. So this brings me to the larger picture, the system behind our designs and the system affected by our designs. One important factor is, of course, the public awareness of the importance of architecture and design. So if we don't stick to our trades, I mean, to the facets that I've talked about before, we are not really needed anymore. We're going to lose the status we have within the community. So then, because we have seen tendencies where engineers say, like, well, the architect is just an artist. He or she doesn't understand anything about construction. Well, this is not true. We have to really go in there and defend ourselves, actually. Like one example. And also, if we only do tool-based formalism and don't care about the user, well, it's not going to be taken seriously by the public in the end. I'm quite sure about that. And this is a big danger. And then this is something I usually say to enthusiasts that claim, that AI is going to take over our profession. I don't believe that's going to happen, because if we don't stick to our trade, like I said before, we are actually going to make ourselves obsolete quite fast. this is a kind of a funny remark, but I think it's true. We need to create designs that are timeless. That is my approach to this, and that can be appreciated by future generation. We should actually also talk about materials. Like we always talk about materials that can be combustible in nature or something like this, or recycled. This is great, but what materials are those exactly? Perhaps we should simply use much more good metals that really are persistent over time. Perhaps that is better, and I seldom hear this being said, actually. We can actually experiment with these. We have all the tools, CNC milling, to create this, or CNC bending. So why only focus on on the recyclable. Although I think that's very interesting, certainly, of course. So we should, but also, I mean, all of these things that I've mentioned with enthusiasts, they are of course trends, right? So we should actually try to avoid trends. How do we detect if a new technology is more of a trend or if it actually contributes with quality? This is a huge question, and I really urge people and my fellow architects and designers to start to discuss this really seriously, because trends is not timeless. They are not something that they're very short-term things, right? So I strongly believe in strategies that aim for long-term design solutions. So my future strategy is both a framework and attitude. And yes, this is a matter of discussion. I'm looking forward to discussing this with anyone who is interested in doing so. So thank you so much for your attention, and I hope to engage in very interesting debates on this in the future. Thank you. Bye.